Okay, welcome back everybody to this afternoon's final lecture, presented by Phil Crump and discussing deep space networking at Goonhilly. So Phil, over to you.
Thank you. So my name's Phil Crump and licensed as M0DNY for a while. And I'm going to talk to you today about a deep space network at Goonhilly Earth Station. So I'm going to run through a personal introduction first, go through a bit of history of Goonhilly Earth Station, and then I'm going to talk about the upgrade of our main deep space antenna, Goonhilly 6, down there, what we've achieved with that upgrade, the spacecraft we currently support, how we're going to expand it in the future, and then I'll take some questions at the end. So firstly, a bit about me. My background is mainly electronics and embedded software until I started working at Goonhilly in 2017. My first exposure to the space industry was actually through supporting the AMSAT-UK school contacts with Tim Peake. And through that I got to know a few people at Goonhilly and then started working there at 2017. Since then, the main project I've been working on has been the upgrade of this Goonhilly 6 deep space antenna, but I've also been involved in a few other projects, notably supporting the Virgin Orbit launch from Newquay, with a couple of deployable ground stations that we deployed to help with that, and then also some SDA research on another of our larger antennas as well. And I've been licensed for a while now. So first of all, talking a bit about Goonhilly itself. So we are, the Goonhilly site is located down on the Lizard Peninsula, down in Cornwall. It's about 6 miles north of Lizard Point, which is the most southerly point in the UK. And here's a wide-angle photo of the site. So this site was picked for several factors. One is that it's quite flat. You can see all the way out to the sea, the other side of the peninsula there. Another reason is that it's sat on, it's about 2 meters of earth, and then it's serpentine bedrock underneath there, which is great for mounting large, heavy antennas on and supporting the weight of those antennas. Of course, it's quite a remote location, but one of the advantages you get from that is it hasn't got as much RFI as more built-up locations. Particularly some of the satellite teleports that are around have been slowly encroached on and have had to restrict the bands they're working in, particularly C-band has been quite heavily affected, and we're outside of the effect of that here. So a couple of early photos of Goonhilly. So obviously on the top right there you've got the construction of the first antenna. So this was built by what was then the General Post Office in 1962. And this is antenna 1 Arthur, which is a 26 meter, and that was built to support video via the Telstar satellite. So it had to be able to track the Telstar satellite as it went over, and it was one of the first antennas to be built of that size and trackable. And it's quite large and it's quite heavy, but it did its job, and it worked well for that for many years. One of the notable things you see on this photo is this is the original reflector that's on Arthur, which was a very deep dish. And that was the original skin put on. That was the surface then had a wooden structure laid over the top later to put a shallower dish on with a so in order to simplify the feed construction, basically the feed construction was quite difficult for getting the proper illumination with that dish. You had to have quite a wide feed on it. On the left, you've got this is the view from the control tower, which actually we still exists on site. We don't operate from there anymore, but we do have a couple of meeting tables up there, and it's a great place to take Zoom calls and have the dishes as your Zoom background. So works well for that. And of course that was part of the visitor center experience when BT ran the site. There's a photo of operations on the bottom right. I don't actually know which operations these are from, but this is in one of the operations control areas that we still use. And there's still a few of these control banks around, although they're not used actively for anything nowadays. So one of the big events that Goonhilly was particularly involved in through Telstar and through the Arthur dish was the global broadcast of the Apollo 11 pictures, and this is quite a bit before my time, so so instead we've got a short video here which was put together by the Science Museum from Pip Greenway, who was one of the operators at Goonhilly there at the time.
There was two very important things that went on: the landing on the moon and Goonhilly handling the broadcast. My responsibility on the night of the broadcast, I was in charge of the television switching, patching from the communication equipment through the various feeds, and then the outlet which would go via the microwave link up to BBC for Europe or for the UK. Now, a lot of people thought that the pictures from the moon came directly to Goonhilly, but they didn't. They came eventually because of a satellite failure over the Atlantic Ocean. It came in by a very long route. It came from the moon to Australia, Australia to America, America across to Japan, and Japan to Goonhilly.
So in addition to that, and in addition to supporting other notable global audience broadcasts, building up in the amount of people they reached, Goonhilly's also been part of other things as well as such as the development of the Intelsat, Inmarsat, Eutelsat networks. A lot of the research for that happened on site, but we were also one of the key nodes in the early ARPANET. So we are this node over here, and provided a cross-Atlantic link via Intelsat 4A across to West Virginia, which then went into the MIT node. So basically between the MIT node and the UCL node on there, and that laid the foundation for quite a lot of the connectivity that now runs through the site as well. So at Goonhilly, we're very proud of the history of the site, and so as part of the 50th anniversary of the Apollo 11, we put on a music festival at the site, hosted around Arthur, where the old visitor centre was, and here is a video of it.
This is Apollo Control at 102 hours into the flight of Apollo 11. It's going quite quiet here in Mission Control. A few moments ago, Flight Director Dean Kranz requested that everyone sit down, get prepared for events that are coming. And he closed with a remark, good luck to all of you. Minutes now until ignition for powered descent. Everything's still looking very good at this point. Okay, all flight controllers, gonna go for powered descent. Retro, go. Final, go. Guide, go. Control, go. Telcom, go. Ginsey, go. Econ, go. Surgeon, go. Retro, go. Final, go. Guide, go. Control, go. Retro, go. Final, go. Guide, go. Roll, go. Go, 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 go.
So we had public service broadcasting there for that gig, which was a really good fit with their music. So as part of that as well, we had several radio amateurs. Some of the team are here, who ran an Earth Moon Earth contact using Goonhilly 6 on 5.7 gig with an Australian station. And late that evening, we had the moon rise behind the stage, and we were able to get a 5.7 gig EME contact via the moon through Goonhilly 6. So that was down to Goonhilly 6, and then we had VHF and UHF link to the stage. Yeah. And it came through boomingly loud, although, as I understand it, was quite difficult to hear it over the enthusiasm of the audience. So we hosted another one-day festival in 2022 as well to mark 60 years of the site itself. So 1962 to 2022. We're not set up to be able to host visitors regularly on the site as BT used to be able to do. We've got the visitor centre there, but it's all been gutted out. There's virtually nothing in it. So there'll be quite a bit of investment needed to put in to open that back up again. But instead, we try and put on these events when we can. And as part of this, we've run guided open-top bus tours of the internal site as well, with the directors mandated to have their shift of providing the guided bus tour there. And I hear that there is the possibility that one might be happening this summer as well. So stay tuned on that. It'll be announced on our website and Twitter if it does go ahead. So now I'm going to talk a bit about the upgrade of Goonhilly 6. So Goonhilly 6, or Merlin, is our largest antenna and our newest antenna, our newest large antenna rather, built by Mitsubishi in 1985. It's a 32-meter antenna, originally built as a C-Ku band dual band antenna for geostationary satellites, particularly Intelsat. It was used heavily during its first years, but then as the technology's moved on, we've moved back towards sort of a 10-meter turning head for the geostationary market, and so this got less and less use. After we took over the site from BT, we did have some use of it, particularly supporting critical operations or where the spacecraft was degraded. We were able to provide support with this with a far higher link margin and a narrower beam width as well if other satellites were close by. But it wasn't really enough to justify the upkeep of the antenna. So in 2015, there was an ESA feasibility study conducted to see whether this could be turned into a deep space antenna and how it could then be integrated as part of ESTRAC's deep space network. And the outcome of that was that, yes, we believe it could. It would be very useful to have a deep space asset in the UK as well. And it also provided us several ways forward on how to achieve that. And in particular at the time, we were looking towards Artemis 1 and whether the UK would then be able to support Artemis 1, NASA's return to the moon. And being a part of that would be something really big. So after this, a proposal was put together, and this was funded by the Cornwall and Isles of Scilly Local Enterprise Partnership. They provided the funding, the capital injection into this in order to build up this infrastructure. And then the UK Space Agency, along with the European Space Agency, provided the technical diligence. So we had supervisory from the UK Space Agency and also from experts working at ESOC, the European Space Operations Centre in Darmstadt, who run the ESTRAC network of deep space antennas. They provided their expertise to help us upgrade the antenna. So going through now some of the bits that were upgraded. So one, the key bits was upgrading the pointing performance. So previously you could only track at 0.14 degrees per second, which is fine if you're tracking a slowly moving geostationary. but for quite a lot of the missions we were looking at, particularly the science missions that are actually in Earth orbit, we needed it quite a bit faster than that. So working with the experts at ESA and also with Vertex, our subcontractor for this, the speed was upgraded to 0.4 of a degree per second. That we were one of the things that has come through this is that we don't have much documentation on the antenna, much design documentation. So there was a fair bit of working out what we could do and then adding a bit of margin onto that. And one of the things was this tracking speed. We went for 0.4 of a degree per second in the end. On the right here, you can see one of the old motor and gearbox combinations, complete with, I think that's one, we had some workers from the Falmouth shipyard come in to help us with this for scale in the background. So you can see that it's about 6 or 8 feet long, and actually it extends out even further on the right hand side. If I move on to the next one, this is now the new motor and gearbox well, actually this is the gearbox combination, sorry. So these are the new gearboxes in red, complete with the drive cogs, and they're with a German engineer for scale this time. That's one sitting on a load test cell, so they all went through I forget what the mechanical term is, but basically a burn-in to make sure that they were in good condition before they're shipped to us, and went through oil analysis and such after these tests. But these are the replacement gearboxes, and then these were installed on the antenna here, and you can see that they're quite a bit smaller. So the old ones came out to about here, and also the motors on the end are far smaller as well. Modern servo motors there. Another bit about the pointing of the antenna was that if I go back actually, this track that runs around that the antenna structure sits on then had a stop at north. So it did about 0.1 degrees round to 359.6. And then obviously you had to come back round again to get to the other side. So one of the things we did as part of the upgrade was increase that up to 540 degrees. So we took out the stop. So now theoretically the antenna can spin as much as it wants, but we also need to get the cables round that. So we added in a cable bander, and this is it in the factory being assembled, which allowed us to do 540 degrees. So basically a full 360 plus an extra 80 degrees. And that's a particular use for some of the Earth orbiting missions that we support, particularly the integral spacecraft, which is in a highly elliptical orbit, such that it'll appear into your sky, circle around zenith for a couple of days, and then disappear off to the other end. And this allows us to support more of that without then having to unwind the antenna again. We still have to unwind the antenna usually once or twice for those passes, but it would be a few more without this extra functionality. So with that upgrade, this is the first test of it. As you can see from the clouds in the background, this is very sped up. It doesn't go this fast in real time. So that's coming around to 360 now, and then it goes through the extra 180 there. So that gives us quite a bit more continuous tracking. So also in this upgrade, we had to do quite a few upgrades to the structure. As you can see from the photos here, these are the before photos. There's quite a bit of surface corrosion. And one of the downsides of being out on that Lizard Peninsula is we have the sea within 5 miles on pretty much every side. All the air is very salty. Particularly when you get a strong wind coming in, you can really taste the salt in the air, and so some of the surfaces there have been a little neglected over time, and you can start to see the rust coming through the paint. So we went over all of this and replaced quite a few parts, stripped the corrosion off, repainted it. One of the things we did was all the bolts on the back of here were inspected, and although most of the corrosion was just surface corrosion, we actually went and replaced, I think, nearly all of the bolts, and that was several thousand bolts, several months of someone being up there on a platform hot working all the bolts in, all the new bolts. But that gives us the confidence that it's now going to last for years to come. One of the other bits that we did was, so this cabin that I'll talk about a bit more about the functional purpose in a minute, but this is basically a metal sheet azimuth cabin, also been referred to as the Wendy house, but the azimuth cabin is a technical name for it. This was all replaced as well. So this was looking at the sheer number of joints up here with all the bolts. So we had it up in this position, and a cherry picker, which actually you saw in the previous video, was up here for several months with a local company working to swap those out. So I mentioned before that we didn't have much design documentation on the antenna. So one of the first things we did was got another local survey company to bring in some laser mapping and 3D mapping, and generated these renders for us, which then allowed us to produce the design spec for the antenna with all the right measurements, which could then be used to design the RF optics. And this was another bit that we needed to look at as part of the upgrade, because we had the old C and KU band horn in there, and that needed to be replaced by something suitable for deep space operations. So this is the design of the new system. So on the geometry of the antenna, so it's a Cassegrain beam waveguide. So you've got the Cassegrain subreflector there, and then that then focuses the RF down an oversized waveguide, so a beam waveguide. These four mirrors then allow it to articulate around the elevation and azimuth bearings, and then this comes down into the feed horn here. So previously, the old C and KU band horn was actually mostly in the base building, which is this bit here. But we wanted to move it up and into the azimuth cabin, so that required changing the focal point of all of this. And obviously these mirrors are quite finely set as to where the focal point is, so we actually ended up swapping out one of the mirrors, M4 there, in order to achieve that, and that's this one at the top here. So that's then the new optical layout looking from the side. So you've got the new mirror here, and our new feed horn actually pokes up through the top of this azimuth cabin. This is the new mirror that went in. So it's quite a large mirror. I think it's about 1 meter across and 1.5 meters top to bottom. And this is it with all the photogrammetry stickers on, so that they could make sure that it was absolutely perfectly aligned to within fractions of a millimeter to get that focal point into the horn, so that the antenna was ideally illuminated for maximum efficiency. And then below that we have the new feed horn network. So this sits vertically, as shown on the right here. But you've got the different colours, different components here. So you've got the yellow corrugated horn, main horn there. You've then got the S-band comes out in pink here, pink purple. And then the blue is the polarizer, S-band polarizer. So we run right hand and left hand circular for each band. So S-band, right hand, left hand, X-band, right hand, left hand. So that is that's for S-band, that is 2.1 gigs up, 2.2 gigs down. For X-band, it is 7.1 gigs up and 8.4 gigs down. So one of the largest components here is the S-band diplexer, and that's not only because the wavelength is quite large at S-band comparatively, but also because I mentioned it's 2.1 up and 2.2 down. So we're transmitting up to 2.5 kilowatts up on 2.1 gigs, and we want to not deafen the LNA on 2.2. And that's what these are about. So quite large filters in the diplexer there. The X-band system, by comparison, is quite a bit more compact, and is actually the grey components that you can just about see here. It's a bit of a blurred image. The white section in the middle then is the X-band monopulse tracking coupler. So this provides a delta error signal for the tracking when the spacecraft is off bore site. We get a signal out of the tracking coupler here. The physics of it, I'm yet to get my head around at all. But basically, if it comes in slightly sideways, it comes out of the side of the waveguide, kind of thing. And then there's lots of cleverness in that, which then means we get a signal out of that, such that the phase of the signal in comparison to the sum signal, i.e. the one normally out the back of the waveguide, the phase of that determines which direction it's off in. And that then, when hooked up to the electronics we've got, then means that the antenna can always pull itself back onto the spacecraft, which is very useful in launch and early operations, where they may not know exactly where the spacecraft is, or the trajectory might be a little out of date. So this is the feed horn, the feed having been constructed. So this is the horn section, the section that was in yellow. This time with some Swiss engineers from MIRAD, who built the feed system for us for scale. And then this is it installed on the right here, as it is in the current antenna. So you've got this is all in white here, is the feed network. And then we've got a support frame around it. And then you can see the top of the horn poking through the top there. And then the mirror is then just above it there. And this all rotates with the antenna. So the whole structure, as it goes around on the rails, the feed rotates with the antenna. Is that right? No, I've got that wrong, of course, because that doesn't work with the waveguide. But we have, so the feed stays static with respect to the base building, and everything else rotates around it. So this is down in the base building. So these are the photos of what it used to look like, with all the old kit in there. So we've got the old C-band TWTs here with the large cooling ducts and the waveguide switching on the top. The center bottom then is the old antenna drive rack. And one of the notable features of this was that the control logic was nearly entirely implemented in a full height panel of relays on the back of one of these racks. And it made quite a din when it was switching around. We had a good bit of fun with that for the Earth-Moon-Earth contact. So the Earth-Moon-Earth contact on 5.7 gigs was of course done before this upgrade was completed, and so we were using this old drive rack for that. Complete with a computer interface built around an Arduino in order to be able to actually put some angles into this of where the moon was. The other feature you can just about see here is a bench power supply sat on one of the racks that was pulled out. So this was where one of the built-in modules had failed, but of course there was no way of getting a spare for something that old, so the bench power supply providing the voltage in had become a permanent fixture as part of this system. And then on the right there, you've got the old air handling units, which provided the cooling for all the C-band TWTs, and those were in need of quite a bit of TLC after quite a few years exposed to the salt air. So this is how it looks now. So we've repainted it. We've put in better lighting as well. The dingy lighting before was as it was. We've put in better lighting, and you'll notice that there's a lot less racks now as well. Everything's become quite a bit smaller, and the racks are also less busy. So you've got the feed. The feed is up at the top here, which we were looking at before. The azimuth cabin sits up here, and then you've got all the cables supporting the feed system and other test loop systems that we have up there. You've got the amplifier racks to the right. You can see the cooling ducts going in and out of the back of them. These will be the S-band amplifier racks. You can tell because of the size of the waveguide on them, and those are the large loads that we use. So we've got two amplifiers for S-band, 2 amplifiers for X-band, and we can run about 2.5 kilowatts on each on those. And then most of the rest of the equipment is built into this rack here. So looking at the front of these racks, you can see everything's quite a bit smaller compared to the previous generation. So we've got some IT systems. We've got a pair of modems, which are the same modems that are used in the ESTRAC deep space networks. These are a product from BAE Systems, built for ESA, and we use the same system as they use, so that in order to support a mission, we can just take the config files that they use, load it into our systems, and we know it's going to be compatible. You've then got uplink converters and some test gear. These are all the downlink converters and switches. The monopulse system, so there was a monopulse system, I believe, for KU band in the old system, which had at least one rack. It might have been 1.5 full height racks for the processing. That processing is now that 2U box at the top there. So quite a bit nice and compact. The next rack is the antenna drive control system and some test loop control as well. And then the final one is our F&T system, which contains some very stable frequency and timing clocks, particularly needed for ranging and Doppler measurements. It's worth noting that although the front of the racks is quite empty, and obviously there's quite a bit of space for expansion, was the idea here. We could cram it into smaller racks, into less racks rather. But we wanted a bit of space for expansion. But also several of these racks, especially the RF ones, have lots of patch panels in the back to enable us to be flexible about what's patched into what. And then this is the control room that we've put together. So this is where our operators sit. This is with the mood lighting running. This is where our operators sit. This is over in the main buildings, so not actually in the antenna building itself. This is over in the main buildings, and they can control all of the antenna functions from here. So what can it do now? So this was actually in the final stages of the upgrade. This is the first time we had all the systems up and running and were able to point it at the spacecraft. And we picked the same spacecraft that I know that Bockham used to test their dish, which is Mars Express. So we've got a decodable signal from Mars Express on there, running BPSK with SPL. And this is several of our team looking very happy, having completed this during the stages of lockdown as well, which added to the logistic challenges a bit. But we were also lucky with the timing to be able to see the Mars 2020 arrival at Mars, and also particularly the descent into Mars. So this was the first big test of our system with a very weak signal. We were looking at the signal off the lander as it went down through the atmosphere. So we did, for this, we actually did an open loop recording on those modems. So effectively an IQ recording, but with some Doppler pre-steering on it. And then this was post-processed out to show the transmissions from the lander as we picked it up from Goonhilly 6. So you can just about see there and there the data subcarriers. They weren't decodable to us. NASA was using their 70 meter to decode those, so we didn't really have a chance. But we can see it then when it switches those off and switches to the MFSK tones that are used to signal the stages of descent. So we saw these tones change at several times. We were looking at the live stream at the time to match this up with events that were happening. We had a loss of signal here, and that was at the point where the live stream announced that the back shell had come away from the lander. So what we were seeing was it being blocked out by the back shell, and then we picked it up as soon as the back shell was out of the way. tracking it for a bit more time there. So the frequency on here is 100 kilohertz top to bottom, and then this is about a minute per panel here. And then this is the exciting bit where we saw an MFSK tone change. NASA reported that they were seeing entry, which we believe to be that tone indicating, and then we saw it start to decelerate as it hit the atmosphere. And we could still just about resolve it at about 100 meters per second squared of deceleration. And it was not soon after that that NASA reported they had also had loss of signal. So that was an excellent first thing to be able to see with the antenna. Also, before descent, we were watching the spacecraft approach Mars, and another thing we were able to discern was using the Doppler measurement with the accurate frequency and timing system. We were able to pull out this waveform on the top right here, which was the spacecraft rotating very slowly as it went towards Mars. So that was only a few centimeters per second velocity each way, but we were still able to discern that, which is a great confidence boost in what the antenna could do. So we then went through mission readiness tests with Mars Express, Integral and Gaia. We're particularly thankful to Mars Express for being the first mission to actually pick us as a station to use and to be happy with us commanding their spacecraft. And that went without a hitch. It was excellent. Integral and Gaia then followed. And these are two actually near-Earth spacecraft, although Gaia is out at the L1 Lagrange point. We were then declared operational at the G7 conference, and the antenna was officially opened by our British astronaut there. And then we've been in 24/7 operations since early 2022. So these are some of the first data we had operationally back from our support of Mars Express. Were these webcam pictures from the Mars Express live webcam. They run a Flickr account where you can see all the latest ones that have been downlinked, and these are ones that were actually downlinked on our first operational support of Mars Express through our antenna, which was excellent to see. We also support some other activities with Mars Express, including radio science, and this is a time lapse of an early morning pass we did for them. This is slightly better than average weather for Cornwall. But that one in particular is looking at the Mars Express spacecraft as it just goes behind Mars, and they can then look at the radio signals and measure the Martian atmosphere from what we've been able to record on the modems. So those are always quite exciting to support. We also assisted with Artemis 1. This was the idea of the feasibility study, was whether the UK could then use this asset to support NASA in returning to the moon. And we were qualified for support of 6 of the CubeSats that went along with Artemis. We ended up supporting being scheduled for support of 3 of them, and we supported several of them through to the end of their missions there. We also supported the Orion capsule itself in providing downlink and Doppler data for that as well. More recently, we supported the ISRO's Chandrayaan-3 mission. So we supported this as part of the ESTRAC network, but we were the ESTRAC prime station for the landing phase and the lunar orbit phase. We weren't able to see the landing itself from the UK. However, several minutes after the landing, we took over support from the Indian stations, and in particular, we were the ones supporting the spacecraft when they rolled the lander out. So we don't get to see the content of commands that are sent through. We don't look at the content of commands that are sent through, but we believe all the commands and video for that came through our ground station, which is excellent to see. It was good to see the success of that, even if it didn't wake up in the previous day. The mission was still a great success there. So the spacecraft we've supported, these are the list of the spacecraft we've supported so far with some sample spectrums on the right. Most of them we do standard TT&C, so telemetry, tracking and control, so downlink, uplink and ranging. But we've also done some other interesting activities, such as the radio science I mentioned with Mars Express, and also supporting Delta Door with Gaia, where between another station we calibrate on a quasar, then look at the spacecraft, calibrate on a quasar, look at the spacecraft, rinse and repeat, and then that gets resolved to being able to pinpoint the spacecraft in space from correlating between two geographically diverse ground stations. And this list will be growing. Intuitive Machines, we will be supporting them on their lunar landing soon. These are the plaques that we have up in our control center of the spacecraft we've supported so far, and this will certainly grow. So how are we planning to expand this now? Well, we've got Goonhilly Earth Station with the Goonhilly 6 antenna up here in Cornwall, but Goonhilly Earth Station has also recently completed the purchase of 2 sites in the US. These are existing ground stations with several near-Earth assets, so they do geo-servicing and some constellation servicing. But we're also planning to build lunar support class antennas at these locations. We're also looking at a location in Western Australia as well, currently doing some site surveys out there. And the idea is that in particular with 3 of these stations, we can then provide 24/7 support of a lunar spacecraft to a customer from our own network here. And I've rushed through the last of that as I realized I was running out of time, but thank you for your time, and do you have any questions?
Right. Thank you, Phil. It is Phil, isn't it? Yes. Yeah. Is the sound on? Okay. There was a lot of content in that presentation, Phil. I would very much like to see that again. Will we get an opportunity to do to see the presentation again? Is it recorded?
It is being recorded, yes, and it'll be uploaded to YouTube on the AMSAT-UK YouTube within a couple of weeks. Yep.
In terms of telecom infrastructure, was that upgraded as well at the same time for the dish, or has that been pre-existing? Because obviously I'm thinking of the old BT days when we're there in terms of fibre, stuff like that. Has that been all upgraded?
So for the deep space support itself, we did put in some new dedicated connectivity into ESOC in Darmstadt, especially for support of the ESA missions. So we have got dedicated high-speed connectivity for that as part of this, yeah.
Do you encrypt the ground segment links you mentioned and the uplink command, or is that end-to-end from ESA and NASA?
So all the ground communication links are encrypted. The space links are up to the customer, and several of them are encrypted.
Could you give us some idea of the gain on S-band and on X-band for the antenna?
I was worried someone was going to ask me for numbers off the top of my head. Adequate is certainly the word. I think on the order of 50 dB on X-band. I can't remember off the top of my head on S-band.
What was the most recent challenge you had? Challenge.
The most recent challenge we've had. Um, it was probably in sport. In support of one of the recent missions, we started to do a bit more LEOP support than we're normally used to, and dealing with in particular, the Doppler offsets of the spacecraft being linked to another ground station, and also as well as the Doppler offset as well, the drift rate that we see from that, and getting the modem. Realizing the issue in real time and getting the modem reconfigured in real time to be able to support that. That's the notable recent one I can think of.
Yeah, with the likes of James Webb going to the K whatever it is band, have you got any plans to go beyond the S and X band?
So K-band was looked at as part of the upgrade. There are some downsides from trying to do K-band from the Lizard Peninsula in terms of weather availability. We are definitely looking at K-band for the other sites and may look at K-band for Goonhilly site itself in the future. Yeah.
You mentioned the old dish, Arthur, as well as the new one you've talked about. Are there other dishes on site, and is the old one still in use for anything? What else is used and usable?
So in terms of large dish assets, we currently have three of this similar class of antenna. We have Arthur Goonhilly 1, we have Guinevere Goonhilly 3, and then this one Merlin Goonhilly 6. Goonhilly 3 is a 30-meter antenna. It's a little older than 6 and requires a bit more work to upgrade it. We are using that for some R&D work, particularly in the SDA and SSA areas. Arthur is being quite a bit older. It's quite an old design with a lot of weight above the azimuth bearing, which makes it quite power hungry to use. We have started working on it. In particular, the azimuth bearings have had some work in the past few months, and we've actually got it turning around. But we are still trying to find a customer who can pay for use of that dish.
We get most of our weather from the south and west. Are there any weather conditions under which the dish might become slightly distorted as to be unusable temporarily?
So we do see in very strong winds we do see a bit of pointing degradation. So you'll see a little bit of signal loss off the spacecraft as the antenna gets pulled off the pointing a little. But not too much in that respect. There are also automatic systems in place that if the wind gets too high, it automatically stows the antenna. And we have, I think, had that happen once in the last couple of years that we needed to stow the antenna. But we were well aware of that from the forecasts. Yeah, that was near 70-mile-an-hour gusts, I seem to remember. It's quite strong.
In between missions, do you close down, or in fact you've got a permanent research facility there?
So most of these missions we're interchanging between on a daily basis.
Oh, right.
Yeah. So we do have periods between support of missions, which we use for maintenance of the antenna and also for new development as well, and for training as well for our new operations staff.
Anybody else? Okay. That is the last lecture for today. However,